Okay, in this video we're going to take a look at the distributive law from algebra. The distributive law states that A times the quantity B plus C equals A times B plus A times C. And we're going to question why this law is true. Actually, a lot of students believe this is a definition. In other words, it's a rule that you follow, and you do it because, we say that's the way it is. But it actually has a reason. This isn't arbitrary. We're going to begin with an example with some numbers to try to appreciate that there really is something to explain here. So let's take the case where A is 3, for example, B is 2, and C is 4. Okay, and I'll replace the A on the right side with a 3, the B with a 2, the other A with a 3, and the C with a 4. Now let's compute each side to see if these really come out equal. Follow the order of operations. On the left, you do what's in the parentheses first, and 2 plus 4 is 6, and then 3 times 6 is 18. On the right, we do the multiplications before the addition. 3 times 2 is 6, 3 times 4 is 12, and then 6 plus 12 is 18. So these came out the same, and it's not a coincidence. This will work for any numbers A, B, and C. Even though the middle step here was different. We have 3 times 6 arriving at 18, and over here we have 6 plus 12 arriving at 18. So there is something to explain here. Alright, before I attempt to explain it in general, let's see what's going on with these numbers 3, 2, and 4. Let me take the expression 3 times 2 plus 4. Now when you multiply something by 3, what does that really mean? For example, when you take 7 and you multiply it by 3, to get that 21, what's really going on is you're adding 7 plus 7 plus 7. You've got 3 copies of 7 that makes the 21. So here we have 3 times this quantity 2 plus 4. So what that's equal to is that 2 plus 4 gets added up 3 times like this. Now you know it doesn't matter how you group your numbers when you're adding them. That's called associativity, and it doesn't matter what order the numbers come in. That's commutativity. So I can rewrite this by putting these 2's in the front of the sum and the 4's on the end. And I happen to have 3 2's and 3 4's. Well, 2 plus 2 plus 2 is otherwise known as 3 times 2. And 4 plus 4 plus 4 is otherwise known as 3 times 4. So without actually doing any calculations whatsoever, we've just explained why 3 times 2 plus 4 really does come out to 3 times 2 plus 3 times 4. Okay, well, this explanation can generalize, meaning it works for other numbers as well. There's nothing special here about the 3, 2, and 4. For example, suppose I keep that 3 the same for a minute, but instead of using 2 and 4, I use a B and a C. Okay, well, 3 times the quantity B plus C means we're adding B plus C 3 times. That's what multiplication is. It's repeated addition. And if I reorder and regroup here, I can put all my B's first. B plus B plus B, there's 3 of them. And then all my C's second. And this is otherwise known as 3 times B plus 3 times C. And so we see that 3 times B plus C is always 3 times B plus 3 times C for any numbers B and C. This number 3 can change as well. You can make that a 5 or a 17. If it were a 17, you'd have 17 copies of this B plus C over and over and over again. If A is any positive integer, then what this A times B plus C would be is it would be B plus C added up over and over and over again until you've added the B plus C A times, whatever A stands for, 3 or 5 or 17. Okay, well, if you reorder these, you're going to get a bunch of B's at the start, followed by a bunch of C's added up at the end. And you're going to have A of these B's and A of these C's. Okay, and that's otherwise known as A times B plus A times C. So we see that A times B plus C equals A times B plus A times C. Okay, and that will work no matter what these numbers are. This explanation I'm giving, though, relies on the fact that this A is a positive integer. The B and the C can actually be any real numbers, though, and this argument works. So you may wonder, what if A is not a positive integer? What if it's negative or 0 or it's some other real number that's not an integer at all? Well, we could go a little further and explain those cases. I'm not going to do that in this video, however, but I'm going to end with a second explanation of this distributive law that will generalize this a little bit further. I'm going to look at a geometric explanation. Okay, I'm going to look at some geometry here. All right, if I take a look again at 3 times 2 plus 4 and compare that with 3 times 2 plus 3 times 4, I'm going to compare these two quantities by drawing some dots. Okay, I'm going to draw, let's say, 3 rows of dots with 6 columns of dots. 2 plus 4 is 6. Okay. So we have 3 rows of dots, and I'll put a dividing line here. We've got 2 columns and 4 more columns, 6 columns altogether. So if I ask you to count these dots, you probably aren't going to count them individually. The quickest way to count them is to take the number of rows and multiply by the number of columns. Well, if you take the 3 rows times the 2 plus 4 columns, this is what you get. 3 times 2 plus 4. It's the number of columns times the number of rows. It's the total number of dots. Well, if you count the dots in groups, first the dots to the left of this vertical line, and then the dots to the right, let's see what happens. To the left we have 3 times 2 dots. That's right here. Okay, to the right we have 3 times 4 dots. That's right there. You want to add those up to find the total dots. That's what you have there. So counting these dots in 2 different ways establishes that these are equal. Okay, you can do this not just with dots, you can do it with rectangles as well. And you don't need to use 3, 2, and 4. If you looked at A times B plus C again, and you assume for the moment that A, B, and C are all positive real numbers, then you can explain this equation by looking at this picture. Draw a rectangle where the height is A and the base is B plus C. Well, if we were trying to find the area of this rectangle, we could take this height A and multiply it by the base B plus C, and this is what we would get. That would be the area. However, if I draw a dividing line to divide this into 2 rectangles, right where I'm dividing the B plus C into lengths of B and C separately, so that this first line segment has length B and the second one has length C, then I can find the total area by adding the areas of these individual rectangles. The rectangle on the left has an area of A times B. The one on the right has an area of A times C. So we want to add those together to get the total area. So looking at the area in 2 different ways establishes the distributive law, at least in the case where A, B, and C are positive real numbers. And notice it doesn't even depend on the fact that A, B, and C are integers. They can be any numbers at all. Okay, perhaps I'll leave the case of negative values and zeros to another video. Thanks for watching.